Welcome to ANT's Digital Pharma World. This is our second lecture of Unit 1 Colloidal Dispersions. Okay, in that today I am going to discuss on classification of colloids. Okay, so we'll see the classification of colloids in this lecture. So, colloids are classified into based on physical state of dispersed phase and dispersion media, and next based on the interactions between dispersed phase and dispersion medium, next based on molecular size in the dispersion medium, and the next is based on the appearance of colloids, and last based on electric charge on dispersion phase. Okay, so we will see one by one in details. It's a 5 mark questions. Okay, before going to the classification part, I will just refresh the last class. Just what is colloids? You're remembering what is colloids? So colloids are nothing but it's a mixture, na? It's a mixture of two or more substances mixed together. Okay, but it is not chemically combined. Okay, and it is dispersed, one is dispersed into another. Okay, so we can consider the colloids are a homogeneous non-crystalline substance which is consisting of large molecules or ultra microscope particles of one substance which is dispersed through a second substance. Colloids which includes gels, sols, and emulsions. Okay, and the particles do not settle, remembering the particle which do not settle and cannot be separated out by ordinary filtering or centrifuging, like in the case of suspensions. Okay, so we'll see what is classification now. Okay, in the first, based on physical state of dispersed phase and dispersion medium. So this is all this table also is from CVS Subramaniam. So always you focus on the tabular columns, flow charts. Okay, highlight your points every time. So to highlight the points is a very nice way. You can either go for your tabular columns presentation or flow chart type. Okay, so we'll see based on the physical state of dispersed phase and dispersion medium. Okay, so based on the dispersed phase, it's classified into solid, liquid, and gases. So dispersed phase may be either it may be a solid or liquid or gas. Okay, so examples also they are given. In the case of solids, zinc oxide paste, toothpaste. Okay, these are the examples of dispersed phase. Dispersed phase, remembering where it got this means the dispersed molecules we can call it as a dispersed phase. Okay, and the next is liquid. The liquids like butter, oil in hydrophilic ointments. Okay, and the next gas, solid foams, pumice are example. Okay, and based on the dispersion medium or external phase. Okay, these are considered as a vehicle of our system. So there are two. Okay, there are two types of dispersion medium or vehicle. One is liquid and another one is gas. Okay, so the liquid we can consider bentonite, magma sols. Okay, and in the gas, solid aerosols and example. Okay, so you just go through this table. And next is very important for 5 marks as well as 2 marks. This alone it will ask for the 5 mark questions. Okay, so we'll see based on the nature of interactions between dispersed phase and dispersion medium is classified into lyophilic colloids, lyophobic colloids, and association colloids. So this lyophilic colloids. So the lyophilic colloids are, we can call it, it's a solvent loving compound, and the next is lyophobic. Okay, so solvent heating we can tell. And the association colloids is also known as amphiphiles. So what is amphiphils? The molecules which is possessing both hydrophilic and hydrolipophilic properties we can call as amphiphils. Okay. So next we will see the tabular column. In the tabular column they are nicely explained the three types of colloids. First we will see dispersed phase. Okay, so in the case of lyophilic colloids, mostly organic molecules are the dispersed phase. Okay, and the case of lyophobic colloids is a largely inorganic particles, and in the case of association colloid it may be aggregation of surface active agents like surfactants, say aggregation of the surfactants. And the nature of interaction in the case of lyophilic colloids, it is stronger and solvent sheet around the particle. And the second lyophobic, it will be little interaction. And in the case of association, is a charge aggregates are solvated. Okay, so the presence of charge in each, in the case of lyophilic colloids, less charged and it is more solvated. Okay, and in the lyophobic it's a highly charged molecules, and in association charged miscellaneous but it is not solvated, but it is solvated, sorry. And in the method of preparation we will see in the lyophilic we can prepare radially from a sole. Okay, and the lyophobic colloids special methods are required, and for association radially from concentration is equal to the critical micellar concentrations. Okay, and the next is viscosity of dispersion. So the dispersion will be higher than that of medium alone in the case of lyophilic colloids, and in the second case lyophobic colloids it's nearly same as the dispersion medium, and the association colloids viscosity increases but not appreciably. Okay, and last is presence of electrolytes, low concentrations and high concentration. Okay, and in the case of lyophilic it is stable, and next lyophobic it's unstable and stable in the case of association. Okay, and lyophilic it's showing the conservation of the precipitates. Okay, and that case it will come as stable, and the association will come as a precipitates. Okay, so we'll see just means explanations of lyophilic colloids. Okay, so the lyophilic colloids means you know this solvent loving. Okay, so it's a medium or a solvent lyophilic colloids. Okay, it's mainly the organic molecules, and it is a soluble, and it is soluble in nature. So what you have to remember is dispersion medium has an affinity towards the dispersion phase, have an affinity towards the dispersion medium in the case of lyophilic colloids. So imagine like I will show you. If you are taking in 1 second, see, this is your colloidal solution, and this is your dispersed phase. Okay, dispersed phase, and this is your dispersion medium. Okay, so the dispersion medium will be your lyophilic colloids. What lyophilic colloids? Because it is solvents or the medium we can call as a vehicle. And it is showing the intrinsic colloids. Okay, and the next is lyophobic colloids. So lyophobic colloids are mostly inorganic particles, you know, and it's our extrinsic colloids and which are unstable in nature. We can give example as gold, AU, and salts of metal hydroxides. Okay, and the last is association or associated colloids. In the association colloids is a miscellaneous. Okay, in the low concentrations it act as a colloids. Okay, like in normal electrolytes. At low concentrations colloids at at higher concentration means These colloids behave normal as a normal electrolyte at a concentrations, at a low concentration, but behave as a colloids in the higher concentration. What do we have to remember? The colloid will be at low concentration, it will show the electrolyte property, and it is in an higher, a higher concentration, it is showing the property of colloids. Okay, so this colloids mainly, I said it is a miscellaneous. So we can give example as soap, higher alkyl sulfonates, and sodium stearate. Okay, so this sodium stearate behave as an electrolyte in dilute solution. Okay, is in dilute solution, this sodium stearate behave as an electrolyte, but in the higher concentrations, it will show the colloidal properties. Okay, you can give that examples. And the next one, so this also anionic, cationic, and non-ionic, you just go through it, and we will see based on molecular size in the dispersed phase. And the next classification based on the molecular size. Okay, size in the dispersed phase, there are classified into three. Okay, one is multimolecular colloids and macromolecular colloids. Okay, so the multimolecular colloids, which is having individual particles of the dispersed phase, which consist of aggregates of atoms or small molecules having the diameter less than 10 to 7 centimeter. So these particles which are held by a weak van der Waals forces of attraction, and we can give as an example gold sol and sulfur sols. Okay, and next one is macromolecular colloids. So these particles of dispersed phase are sufficiently large in size, okay, large in size enough to be a colloidal solution. These are called natural polymers. We can give example as starch, cellulose, and proteins. Okay, and we will move to the next classification based on appearance of the colloids. Okay, there are two, one is sols and one is gels. Okay, sols are nothing but when a colloidal solution appears as a fluid. If the colloidal solutions appears as a fluid, we can call it as an sols. Okay, the sols are generally named as dispersion medium. When the dispersion medium is water, this is known as hydrosol or aquasol. Okay, so when the dispersion medium is alcohol, okay, or benzene, it is called as alcohol and benzosols respectively. Okay, and we will see in the next gels. Okay, when a colloidal solutions which has appears as a solid, we can call it as a gels. Okay, sols are when colloidal solution is fluid, we can call it as sols. Gels when it is as a solid, we can call it as gels. The rigidity of gel varies from substance to substance. Okay, so you can give the example jelly, butter, cheese. Okay, and the last, we'll go for the next classification based on electrical charge. Okay, so we know this colloids having the electrical charge, right? So based on the electrical charge on dispersion phase, there is classified into positive colloids and negative colloids. Okay, so in the positive colloids means the dispersion phase which will carry a positive charge, and in the negative dispersion phase which will carry a negative charge. Okay, so we'll see positive colloids mean when dispersed phase in a colloidal solutions carries a positive dispersion phase. Okay, it is affecting a dispersion phase, it is carrying a positive, means it is called as positive colloids. And if negative negative charge is carried by a dispersion phases, we can call as negative colloids. For positive colloids, we can give example as metal hydroxides like ferric hydroxide. Okay, etc. And negative colloids, we can give silver sols and copper sols. Okay, so this is about today's lecture. I hope you understood. Okay, same as I'm telling you people, if you are not able to understand any of topics of pp2 of this unit, you can comment below, and I will soon upload a video. Okay, thank you for watching. Have a good day.